Hello everybody, how y'all doing? Today we are going to be solving this integral equation which has differentials into it. And this is a part of the homework. It's not a start question. Is it going to come on the midterm? I'm not too sure, but if it does come, it is since it's on the homework, then it's fair game. You can't complain. So I'm gonna go through it. It looks complicated, but it's pretty simple. You guys are probably looking at it like, what the hell is this? I have y of x equals 2 plus a integral that has bounds of x, but is in terms of t. And so if you guys remember the simple concept that if I multiply this by 2, I multiply everything else by 2, you can do the same thing with differentials or derivatives. And you're like, okay, why are you deriving this? How do I get rid of this integral? The one way I can get rid of this integral is if I derive it. Because if I have the derivative of y and I integrate it, it will give me my y. And if I derive my y, it will give me my y prime again. So if I do an integral of y prime and I give it d of dx, shouldn't these cancel out? Right? So that is the simple concept, but there's more to it actually. But that is just the simple concept to it. So I'm gonna rewrite it. Y of x. Ooh, actually, why am I writing all the way to this side? There you go. So I have my y of x. I don't know why I'm rewriting it. Good. Okay, so I'm gonna differentiate my y of x. Right, and then that means I have to differentiate everything else. Right. So. Oh, that's supposed to be an x. Alright, and that is written out. Now, when I differentiate this, what does this side become? It becomes dy over dx, or in other terms, y prime, same thing, equals, when I differentiate 2, the derivative of a constant is 0, right? Plus, now I am going to integrate, I'm going to derive this. Now, when you derive an integral, if you remember for your fundamental theorem of calculus, if you have a integral with a function as its bound, okay, or I could do, x squared, and then inside I have my f in terms of t. And I differentiate this. Oh, it has to be a constant at the bottom as well. If I differentiate this, right? If I differentiate this, what will happen is this will equal your function, right? Your function, but in terms of this. So this will replace t. All right? And that is times the derivative of that input. All right? That is the fundamental theorem of calculus in a nutshell. All right? So now when you want to apply this here, you could do the same thing. And when I differentiate this, what will happen is, let's take this aside. And what will happen is your x will replace your t. Right? And then all this times the derivative of our x. Derivative of x, or there you go, like this, which is just 1. So this whole thing just goes to 1. All right. I'm going to remove this. All right, so this whole thing goes to 1. And so when we rewrite this here, what we'll have is x minus x, right? And then y of x is just y, same thing. Now, when you look at this, this looks like, remember how I said this is y prime? Same thing. So this actually looks like your y prime. I don't know why I write my y's like this. Y prime equals x minus xy. And this is now a differential equation, right? Now let's solve for this differential equation. What we can do is dy over dx. We gotta isolate, so I'm gonna pull out an x. I'll get 1 minus y. Right, now I gotta take y to the left side, have x on the right side. I'll have dy over 1 minus y. equals x dx, right? Now what I'll have to do is I'll have to integrate. So an integral here and an integral here. Now the integral of the right side, I'll do it in a different color. The integral of the right side, what it will be, you have 1 over 1 minus y. I can do a u sub, which equals 1 minus y, right? And my du is just my dy. Now, if I sub this in, what I'll get is 1 over u, the integral of du, right? And then when I integrate this, I'll have a ln. But don't forget that this, oops, yeah, don't forget, wait, what am I missing here? I feel like I'm missing something. 1 minus u, and then when I derive, this becomes a 0 minus, oh, that's what I missed. I see what I missed here. Your 1 minus y would be actually a negative dy, right? Don't forget that negative right there, because this, the derivative of this is 0, the derivative of this is negative 1, right? So that's what I missed. Now I have the integral of 1 over u negative, because of my du, because this I'll divide it by negative 1, divide by negative 1, right? And so I'm going to take this negative out. I'll have 1 over u du. And now the integral of this is 1 ln of u. Sub this back in, we'll get negative 1 minus y. Okay, so that's the derivative of this side. Now, let's rewrite this. This will be negative ln, we got my ln here, all right? And this will be, right? And then the integral of my x will be 1 over 2 x squared. So far, so good. We've solved for this integral, which is, well, we didn't solve for the integral. We solved this equation. And now what we want is actually we want a solution. We want a full answer. And so the question is, what do I plug into this equation? So when I go to the original, when I go to this equation, the original here, which was y equals 2 plus the integral of x, 2, t minus ty to the t. Now, in order for me, also my plus c, in order for me to solve for this and solve for my c, by the way, the c, in case you guys haven't been listening the past decade, this here would be a plus c, and this here would have this would be plus c1, and this would be plus c2. Now when I take this to the other side, what I'll get is c2 minus c1. And I'm going to name this whole thing equals to c. And that's why right here, I just have a c. Make sense? So this wouldn't be there, right? And so I replace this with c, and that's why it looks like this. 1 minus y equals 1 over 2 x squared plus this. All right? Okay, so back here. Now, how do I get 2 points? In the question, it did give me 2 points. How can I solve for my c if I don't have 2 points? One thing we can do is, if you remember in your integral, if you put 2 for x, if I sub in 2 for x, what will happen is, so you see here I have my y in terms of x. Let me delete these two. So here I have my y in terms of x. If I choose 2 as x, then what would happen is this whole integral will turn to 0, because the integral from 2 to 2 is 0. So y at x, well, sorry, not at x, y at 2 equals 2 plus, this turns into 0. That is one of the rules, is if you integrate from a to a, or from b to b, or from 2 to 2, or from whatever to whatever, the same number, same constant, you get 0. You can't integrate. You're basically saying, let's say this is your curve, right? And the integral is the area under the curve. And what you're doing is you're telling it, I want from here to here, which is 0. But if you say from here to here, obviously the difference would take the top and the bottom. But that is another subject. but just to explain quickly, okay? So what this do now, we have y at 2 equals 2. Now I have 2 points. I have my x and I have my y. Now to solve for my c, what I can do is I can just I can plug my numbers in. So ln 1 minus 2 equals 1 over 2 squared plus c. And what will happen here is we'll get 1 minus 2 is negative 1. We're taking the absolute, right? So this is ln of negative 1 equals 1 over 2. This would be 4. So times 4 plus c. All right. And what we'll do here, ln of negative 1, this is the absolute. Ln of 1 is 0. All right. So we have 0. This whole thing turns into 0. And then we'll have 1. Well, let's simplify this. So half times 4 is 2 plus c. So now this goes to the other side. We get negative 2 equals c. Now that we got our negative 2, we go and we're going to sub it back into, where's my equation? Into this equation. So I'll have is negative 1 minus y equals 1 over 2 x squared minus 2. Now, to isolate, what we'll do is negative ln, what can we do here? We can multiply by the negative, get rid of the negative, so do that. This will be negative 1 over 2 x squared plus 2. And then we gotta get rid of our ln. So absolute of 1 minus y equals, what do we have here? E to the negative 1 over 2 x squared plus 2. And what we'll do here is get rid of the absolute, which is going to be plus minus e negative 1 over 2 x squared plus 2. All right, now get rid of the get rid of the 1. So we'll have, yeah, so we'll have plus minus e to negative 1 over 2 x squared plus 2. And since we took the 1, minus 1. Now we take the negative to the other side. We'll have y equals, this will be a positive 1 now, plus minus e to negative 1 over 2 x squared plus 2. But remember from earlier, our y at 2 equals 2. Right? And so if we sub this in, if we sub this x into our x here, what we're supposed to get is a positive number. And so what we'll do is here, if we do this, and I'll have you guys confirm this. Watch this. So if we do e, then negative 1 over 2 squared plus 2. All right. Now if we simplify this, this becomes 4. 4 times the half is negative 2. Negative 2 plus 2 is 0. So e of 0 is just 1. And now we're doing 1 plus and then minus. But that doesn't add up because 1 minus 1 is 0. And that's not what we had here. So this has to be a plus for us to get 2, which is to confirm this. So the answer is y equals 1 plus e negative 1 over 2. Well, not 2, sorry. This would be x squared plus 2. And this, my friends, is your solution to that integral.